All right, section 2.3, we are going to be talking about extrema and end behavior of functions. We'll start with end behavior functions. This is describing the behavior. Drop the cap to my pen. This is describing the behavior of the function at the ends of the graph. So as x approaches positive infinity, in other words, as x gets really large in the positive direction, and as x gets really large in the negative direction, what is the function doing? What are the y values doing? When in Algebra 2, pre-calculus, calculus, when we talk about when we talk about what are the function values doing, what we mean is what are the y values doing? What are they approaching? Okay, so in this first example, and this is how we set them up or how we write our answers when we're asked end behavior, we'll say, as x approaches positive infinity, what are the y values doing? And as x approaches negative infinity, what are the y values doing? So let's figure it out. As x approaches positive infinity, where is y going? Well, y is going to be approaching. Let's look. So as x moves to the right, so as we trace the graph to the right, what are the y values doing? They're going down. They're going to negative infinity. Okay. What about the other direction? Well, as x approaches negative infinity, in other words, as we go in this direction, the function values are going up. Okay, so we'd write that y is approaching positive infinity. Okay, let's do another one. This one is just a line, all right? This one's going to go like this and like that. So as x approaches positive infinity, so as we move to the right, as we trace the graph to the right, what are the y values doing? They're approaching positive infinity as well. Now, like I said, we can say we can use y values in place of function values. They mean the same thing. So sometimes you might see it written like this. F of x approaches positive infinity. Again, because as you move to the right, the function values go up. They approach positive infinity. As you move to the left, the function values approach negative infinity. So f of x approaches negative infinity. The y values approach negative infinity. I'm probably going to stick to y's, but I just wanted to show you the f of x notation in case you see it. You're not so confused by it, all right? All right, let's look at this one. As x approaches positive infinity, what are the y values doing? This would be a good spot to pause and try it and see how you do. As I trace the graph to the right, the curve is going down, so y is approaching negative infinity. As we move to the left, the graph is going down as well, so y approaches negative infinity. So when you're asked for the end behavior, you need to put both of these things, this and that, because you're checking both ends of the graph, okay? All right, so let's move on here. Describe the end behavior of the linear function. So the end behavior of the linear function here, this is just a horizontal line, okay? So we'd write this, as x approaches positive infinity, so as we move to the right, y approaches, well, it's always at 4, so y approaches 4. As x approaches negative infinity, y, so as we move to the left along the line, y is always 4 still, so y approaches 4. You can even write for both of those that y equals 4 because it does. It is 4 in both directions. Either way is fine. And that's it for end behavior. So let's move on and talk about extrema now. Extrema are maximums or minimums in the graph of a function. Okay, so we'll start with relative maximum. Those are high points in the graph or places where there's no nearby points that have a greater y value. So right here would be a relative maximum. Okay, you can see how it's the highest point in the area. Okay, then over here, this would be a relative minimum. No nearby points have a lesser y value. In other words, it's a low point. So this would be a relative minimum. Okay, relative max, relative mins. Sometimes these are called turning points. Why are they called turning points? Well, if you trace the graph, maximums and minimums are where the graph turns from going from decreasing, so right here you could write this, that it's decreasing right here, and then it turns to increasing. Decreasing means it's falling as you move from left to right. Increasing means the y values are going up, or it's rising from left to right. So there it's increasing. And then over here, it turns again, so it goes from going up to going down to decreasing. All right, so that's why they're called turning points. If you trace the graph, that's where the graph turns. Either changes from decreasing to increasing or increasing to decreasing, going up or down from left to right. Right? In the graph below, estimate the zeros and the coordinates at which the extrema occur. All right, so a little bit of vocabulary here. Estimate the zeros. Zeros are where the graph crosses the x-axis. In other words, where the graph function values are equal to 0. So here are where the zeros are. Here, here, here. So we have zeros at approximately x equals negative 2.5, x equals negative 0.5, and x equals 0.5. These are just approximations. Okay, so if you said 0.6, you'd still get this one right. Right? Below, estimate the zeros and the coordinates at which the extrema occur. All right, so let's check for the extrema now. There is an extrema right here. That's a relative max. So we have a maximum. You should really write relative max, but I don't have a lot of space. So I'm going to write maximum, and that is at negative, I don't know, maybe 1.8. So negative 1.8, and then up to, I don't know, maybe 8, approximately. And then we have a relative minimum at, looks like about 0, negative 2 maybe. So here we have a min. Here we have a max. Right? And I'll show you eventually how to find those values exactly, but for right now we're just kind of talking about the features of the graph, trying to approximate where they're located so that we can easily identify them later on. All right? Estimate the turning points and the zeros of the graph below. So again, this is one you should give it a try, see how you do. I'm going to work through it right now. Hopefully you paused. We have one extrema right here. We have a relative max. Okay, so we have a max at, would that be about 0.4 it looks like? All right, and so that's our only turning point. So we just have one turning point, and then what are the zeros in the graph approximately? Well, it looks like we have a 0 right here at negative 2, and 0 right here at 2. Okay, so we have zeros at x equals negative 2 and x equals 2. Zeros are just x-intercepts, remember that, okay? Well, that's how you find zeros, is you just find the x-intercepts. You don't list them like a point, you write x equals, because those are the x values that make the function 0. All right, and that's pretty much it for section 2.2 or 2.3. Some new vocabulary there, so you're going to want to make sure you read the instructions carefully and understand what they're looking for in each problem. But otherwise, there's not much, not a ton of new stuff in this section.